Hello everyone, the paper we're solving today is Alevels Math Paper 3, Winter 2015, Paper Variant 2, Paper 3-2. Alright, so the first question is a modulus inequality. Modulus 2x minus 5 is greater than 3 whole modulus 2x plus 1. So you whole square both sides. So you're left with 2x square minus 2 times 2x times 5 plus 5 square is greater than 9. 2x whole squared plus 2 times 2x times 1 plus 1 whole squared. Simplifying this would leave you with 4x squared minus 20x plus 25 is greater than 9 bracket 4x squared plus 4x plus 1. Further simplification is greater than 36x squared plus 36x plus 9. Bring this all over to the left side to solve the inequality, so that minus 32x squared minus 56x plus 16 is greater than 0. Multiply both sides by minus 1, so our x square's coefficient is a positive number. So 32x squared plus 56x minus 16 is less than 0. And factorize this. So 4 bracket 8x squared plus 14x minus 4 is less than 0. 8x squared plus 14x minus 4 is less than 0. And you can use middle term breaking to solve this inequality, so that 8x squared plus 16x minus 2x minus 4 is less than 0. Now factorize, so that 8x x plus 2 minus 2 bracket x plus 2 is less than 4, and we're left with 8x minus 2 is less than 0. Make a quadratic curve. This minus 2, let's call this 1 over 4, and we need the part which is less than 0, which will be this part. So my answer for question 1 lies between minus 2 is less than x is less than 1 over 4. Question 2 says, using the substitution u equals 3 to the power x, solve the equation 3 to the power x plus 3 to the power 2x equals 3 to the power 3x, giving your answer correct to 3 significant figures. So they've given us the substitution, which is u equals 3 to the power x. So 3 to the power x plus 3 to the power x whole square equals 3 to the power x whole cube. And now if we substitute in our u, so this gives us u plus u squared equals u cubed, and bring these all over to one side, so u cubed minus u squared minus u equals 0. Factorize out u, so u squared minus u minus 1 equals 0. Don't divide by u or you'll end up losing a solution. So we say that u equals 0 is one solution, and u squared minus u minus 1 equals 0 will give us the other solution. Put this all into the quadratic formula, so minus u equals minus 1 plus minus under root minus 1 squared minus 4 a c whole upon 2a. So the answers I'll get from this are u equals 1 plus under root 5 over 2 and u equals 1 minus under root 5 over 2. And then I can equate this to my original substitution, which was 3 to the power x equals u. So I know that 3 to the power x equals 1 plus under root 5 over 2 and 3 to the power x equals 1 minus under root 5 over 2. And then I can just ln both sides. So ln 3x equals ln 1 plus root 5 over 2, and same for this side, ln 3x equals ln 1 minus root 5 over 2. Now the answer over here will be undefined because 1 minus under root 5 over 2 gives you a negative answer, and logs can never be the input for logs can never be negative, because the graph for logs always look like this. They never reach the negative x-axis. So this will be undefined, and you can write it so. And for this part you can use the power rule, so that x ln 3 equals ln 1 plus under root 5 over 2, x equals ln 1 plus under root 5 over 2 whole over ln 3. The only answer for x is 0.438. Alright, moving on to question 3. They've given us a system of simultaneous equations where we'll have to use the compound angle identities. So three, and we know that tan x minus y and we know that tan x minus y equals tan x minus tan y over 1 plus tan x tan y is the compound angle identity for tan. So we can break this up saying that tan theta minus tan y over 1 plus equals 3, and our other equation is tan theta plus equals 1. So from here we can make tan theta the subject and substitute it into the first equation. So what we'll be left with is 1 minus, oh wait, equals 3. Simplify this and open the brackets, so we're left with 1 minus tan phi minus tan phi over 1 plus tan phi minus tan squared equals 3. So this becomes 1 minus 2 tan phi, the numerator, and the denominator we can take to the other side and multiply, so that it becomes 3 plus 3 phi minus 3 tan squared phi. Take this all to one side, to the left side, so that it forms a quadratic in tan squared, which will be 3 tan squared phi minus phi minus 2 equals 0. We can use middle term breaking over here, so there's no need for the quadratic formula. we can break minus 5 into minus 6 and plus 1. So we're left with 3 tan squared by minus 6 minus 2 equals 0. Factorize it and we'll be left with and 3 tan plus 1 equals 0. And my two answers for tan 5 will be equals 2 and tan equals minus 1 over 3. So now I can put these back into my tan theta equation, which was tan theta equals 1 minus tan phi. So for tan theta equals 2, so for tan phi equals 2, tan phi equals minus 1 over 3. Tan theta will be equals to 1 minus 2, which is minus 1, and tan theta will be equals to 1 minus 1 over 3, which in turn gives me a 4 over 3. And now I can solve these for phi and theta. So starting off with this, my alpha angle will be tan inverse of 2, which is just 63.4 degrees. Since tan is positive over here and tan is positive in these are the quadrants, and tan is positive in A and T in the first and third quadrants. So 63.4. The two answers I get, the one answer I get between 0 to 180 range from this answer will be 63.4 degrees. We do the same for this, so alpha equals tan inverse of 1 over 3. We disregard the negative sign for now. So tan inverse of 1 over 3 gives us 0. Tan inverse of 1 over 3 in degrees gives us 18.4. We sketch the quadrants, and since tan over here is negative, it won't be in the first or third quadrants, it will be in the second and fourth quadrants. So 18.4, this answer goes out of our range again. Our range is 0 to 180. So 63.4 was out. This one will be out because it starts from over here. So the only answer I'm getting from this range will be 180 minus 18.4, which gives me 161.6. And we do the same for these answers. So alpha will be, which is just 45. Since it is negative, the answers will lie in the second and fourth quadrants. 45. This goes beyond my range again, so the only answer I'll get from this is 180 minus 45, which is 135. And the last answer, alpha, will be tan inverse of 4 over 3, which is 53.1. Since it's positive, my answer will lie in the first and third quadrants. 53.1, 53.1. This goes beyond my range again since it's greater than 180. So the only answer will be 53.1. So my 4 answers for this system of simultaneous equations are 63.4, 161.6, 135 and 53.1. Now moving on to question number 4. The equation x cubed minus x squared minus 6 equals 0 has one real root denoted by alpha. Part 1. Find by calculation the pair of consecutive integers integers between which alpha lies. So let's call this equation, let's denote this using fx equals x cubed minus x squared minus 6. And if we do trial and error, f of 1 gives us a value of minus 6, f of 2 gives us a value of minus 2, and f of 3 gives us a value of 12. So since the curve changes the y-axis, it goes from negative y-axis to positive y-axis in between these two x values, we can conclude that the root lies in between x equals 2 and x equals 3. So that's part 1 done. Part 2 says show that if a sequence of values given by the iterative formula this converges, then it converges to alpha. Okay, so we have the formula x equals under root x plus 6 over x. And what this part essentially asks us is to get this back into this form or vice versa, get this to this form. So let's start off by this form. We can whole square both sides so that we're left with x squared equals x plus 6 over x. We can multiply both sides by x to get rid of this denominator, so we're left with x cubed equals x squared plus 6, and bring it all to one side, so x cubed minus x squared minus 6 equals 0, which is the equation we originally had. So we can say hence shown. Part 3. Use this iterative formula to determine alpha, correct to 3 decimal places, give the result of each iteration to 5 decimal places. Okay, so we know that the root lies in between x equals 2 and x equals 3. So we use our iterations. Let's take the middle value, x1 equals 2.5, and start inputting the values into this formula. So first you put 2.5 in, you'll get the second value of x as 2.21359. Then you put this back into the formula to get the third value of x, which is 2.21904, and you input this again so that the value you get is 2.21876. Notice that they've asked you to give the answer of each iteration to 5 decimal places and alpha correct to 3 decimal places. So we'll get our answer when the 4th decimal place is static and our third, and then we can round off to 3 decimal places. So x5 is 2.21878. And notice that this and this are the same. The 4th decimal place is now static, so we can round it off to the 3rd decimal place. So my answer will be 2.219. this is the answer for x. Now moving on to question 5. The equation of a curve is y equals e to the power minus 2x tan x for 0 inclusive to 1 over 2 pi. Obtain an expression for dy upon dx and show that can be written in the form e to the power minus 2x a plus b tan x whole squared, where a and b are constants. So for part 1, we just have to differentiate y equals e to the power minus 2x tan x. Since these are two separate functions, we'll use the product rule. So we can say that u equals e to the power minus 2x, and then u prime, which is the differential of this, will be minus 2 e to the power minus 2x. V equals tan x, and the differential v prime will be sec square x. The product rule says dy over dx equals vu prime plus uv prime. So minus 2e to the power minus 2x into tan x plus e to the power minus 2x sec square x. Notice that they want e to the power minus 2x to be factorized out, and the answer should be in terms of tan only. So e to the power minus 2x factorized out will leave us with minus 2 tan x plus sec square x inside. The Pythagorean identity tells us that tan square theta plus 1 equals sec square theta. So that is what we'll use over here, since the answer demands that we use tan only. E minus 2x bracket minus 2 tan x plus tan square theta tan square x plus 1. So e to the power minus 2x bracket tan square x minus 2 tan x plus 1. And this we can complete the square for, or actually just factorize it. It's already completed the square. Tan x whole squared minus 2 and now we can collapse the identity, so that we're left with e to the power minus 2x bracket minus 1 plus tan theta whole squared. So that's part 1 done. Dy dx equals this. And part 2 says explain why the gradient of the curve is never negative. It is never negative because for value 0 inclusive x, which is less than pi over 2, dy dx will never be negative. Dy dx will never be less than 0 or negative. And part 3 says find the value of x for which the gradient is least. The gradient of least is probably should be where the function is at its minimum point, right? So we equate, and to find the minimum point we equate dy over dx to 0, and that is what we'll do here as well. E to the power minus 2x tan theta minus 1 whole squared equals 0. So e to the power minus 2x equals 0 will give us one answer, and tan theta minus 1 whole squared equals 0 should give us the other answer. This will be undefined because if we ln both sides, we're left with minus 2x ln e equals ln 0. Since logs never touch the y-axis, the graph for logs again looks something like this. Since they never touch the y-axis, we can say kx will never be 0, hence this part will be undefined. The second one should give us an answer. So we can square root both sides. So we're left with tan theta minus 1 equals 0. Tan theta equals 1. Theta equals tan inverse of 1, and theta will give us pi over 4 radians, which is our answer.